So continuing in section 6.1, we're going to look at another way to find the volume, and this is called the disk method. And this is when we're revolving a curve about an axis. It can be used to revolve curves around other lines as well, but we're going to start out with revolving about the x-axis. So the idea here is that when you take that curve and you spin it around an axis, the cross section is going to be a circle. And as you know, the area of a circle is pi times the radius squared. So this develops naturally from the last method. So again, we're just taking the area and integrating it over an interval. Again, in this case, though, the area is the area of a circle. So what we're interested in finding is the radius. That's going to be the distance from the edge of the curve to the axis of revolution. In this case, we're looking at the curve y equals the square root of x between the x values of 0 and 4. So the radius, it's the distance from the curve to the x-axis. It's just going to be the square root of x. So we can go ahead and find the volume. So it's from 0 to 4, and it's pi times that radius, which is the square root of x squared dx. I'm going to bring the pi in front of the integrand. Ooh, let's fix that 4. The square root of x squared is simply an x. So when we integrate, we're going to have x squared over 2. And we're looking at it over that interval again from 0 to 4. 4 squared is 16. 16 over 2 is 8. Minus 0 squared is 0. 0 divided by 2 is 0. So we have pi times 8 minus 0, or 8 pi. We can extend this method if we rotate about the y-axis. It works very similar. If you rotate about the y-axis, again, you're going to take a curve, this time rotating it about a vertical axis. Oops. The formula is going to work the same way, except you're integrating with respect to y. So C and D in this case are going to be y values. And the radius here is going to be the distance from the y-axis, or the distance from that vertical axis of revolution. In this case, we are given the curve x equals 2 over y. And that's going to be our radius, the distance from the y-axis to the point on that line. And the interval here is from 1 to 4. So we've got pi times the radius, which is 2 over y, squared dy. I'm going to bring the pi in front. So that gives me 4 over y squared dy. When we integrate, we're going to end up with negative 4 over y. And we're going to evaluate that from 1 to 4. Negative 4 over 4 is negative 1, minus negative 4 over 1 is negative 4. So we have negative 1 minus negative 4. That's negative 1 plus 4, or 3. So here our volume is 3 pi.